This experiment is strain measurement using strain gauge. So this experiment, the objective of this experiment is to determine the Young's modulus of the given cantilever beam using the strain gauge. See, you can see the experimental setup. Here we have a cantilever beam. The cantilever beam is loaded at the free end, and here we have the strain gauges. Here we have the strain gauges. The strain gauges are fixed with the uh, supported end of the cantilever beam, and from here we are taking the wires connections to the uh, this instrument, and this purpose of this instrument is to connect different type of bridges. That is, we are going to calculate the strain using Wheatstone bridge. In the Wheatstone bridge, there are different type of Wheatstone bridges are there. One is quarter, another one is half, another one is full. So for connecting different type of Wheatstone bridge, this is used, and after that, that is connected with this instrument that we can get the strain value. We can get the strain value. Here, the strain gauges are fixed in the cantilever beam, and that will absorb the strain at this location. What will happen is when the load is applied, this part of the fixed end of the cantilever beam will be subjected to strain. So when it is subjected to strain, the strain gauges are fixed over the surface. That also will be subjected to strain. When the strain gauges are subjected to strain, there will be a change in resistance. By measuring the resistance, you can find the strain. So these two are the strain as well as resistance, change in resistance will be proportional. So using that technique in the Wheatstone bridge, the strain in the cantilever beam are measured. Now the length of the beam is 121 millimeter. Breadth is this beam. Breadth is 25 millimeter and depth is 3 millimeter. These are all the datas. And now you can see this is a device which is used for connecting different types of Wheatstone bridge, like quarter, full, and half bridge. So in all three cases, we will be measuring the strain for different loading conditions. Next, so here, see, this is a knob which is used to connect different bridges. If you now this is coinciding with the quarter bridge. When you rotate this clockwise direction, so this is half bridge. So again you rotate, this will be the full bridge. So connecting different bridges, we can use this knob. This is for selecting the channels, because in this experiment there are number of channels are there, 1, 2, 3, 4, up to 10 channels are there. The quarter bridges, that Wheatstone bridge is connected with the channel 4. This is a Wheatstone bridge, quarter Wheatstone bridge channel, and this 8 is the half Wheatstone bridge channel. This is a full. This is a full. So by rotating this knob, we can select channel 4, 8, or 10. Anything you can select. And here also you got to select the whether it is quarter, half, or full. We can select. By selecting this, you can get a strain for the particular case. So this is a digital indicator. Here you can get the strain values. Now again, the entire experiment is shown. So here we have the masses. So now 100 kg, 100 grams are applied. So that is 0.1 kg. So this experiment is repeated, increasing slowly. Initially 100 grams, after that 200 grams, 300 grams, 400 grams, and 500 grams. While loading, unloading. So both time you have to take the strain values. You have to take the strain values. So this value is corresponding to the 100 grams load. So here you have for after completing one experiment, Then you have to change these two knobs. Now this is showing off bridge, and here you have to change the channel also. So this is a tabulation. The tabulation for 100 grams, 200 grams, 300 grams, 400 grams, 500 gram load. Then that load you convert it into Newton. So to convert kg, this is in grams. You convert this into kg. If you want to convert kg into Newton, you multiply with 9.81. By multiplying with 9.81, you can convert it to Newton. So convert it to Newton. Then you find the strain value during loading, unloading, then mean value. That you have to multiply with 10 power minus 6. 10 power minus 6. Whatever value you get, multiply with 10 power minus 6. That will give the strain value for different loadings. Then you can find the Young's modulus. Then you can find the Young's modulus using the equation. So now, and I will give you some other equation to find the Young's modulus. Now, this is a cantilever beam. This is a cantilever beam. Here this end is fixed. Here this end is fixed. So here we have the strain gauges. Load is applied here. Load is applied here. We have the strain gauges here. What this strain gauges will give? This strain gauges will give strain at this location. Strain at this location. What is stress? What is Young's modulus? Young's modulus is equal to stress by strain. Stress by strain. So at this location we know the strain value using the Wheatstone bridge. So now if you are able to calculate the stress at this point, you can find the Young's modulus. So now strain we get from the instrument. Stress value you have to find. How to find the stress value? That is already we have studied in bending. M by I is equal to sigma by Y. So from this sigma, stress is equal to M by I into Y. Now for this beam, the cross section will be like this. This is a cross section. So this is B and this is the D depth, and this is a L and this is a L. All these values are given. All the values are given. Now if you want to find the value of M, what is M? Here load is applied. What is M in this problem? M is equal to W into L. W into L is the M. You substitute W in Newton, L in millimeter. So you will get Newton millimeter, some value. Then what is the value of I? I is equal to BDQ by 12. BDQ by 12. So we know the value of B and we know the value of D. You can find this also. You substitute B in millimeter, D in millimeter. So you will get millimeter power 4. What is Y? Y is equal to D by 2. D by 2. That also you find in millimeter. You find in millimeter. You substitute in this equation and find the value of sigma. Find the value of sigma. So this you have to calculate for each load. 100 grams, 200 grams, 300 grams, 400 grams, 500 grams. Right? If you know the stress value, how to calculate the Young's modulus? Stress by strain will give the Young's modulus. So this is a way you have to calculate the Young's modulus. After that, Young's modulus is a material property. So after that, you find the average. The same procedure you can repeat for. This is table 1. Similarly, you have to put 3 tables. This is for quarter bridge. Similarly, you have to do for half bridge and full bridge also. Right? Then model calculations. Then after that, you write the result for a quarter bridge, half bridge, and full bridge. You write the value of Young's modulus. This is only for quarter bridge. So similarly, you have to take 3 tables. For quarter bridge, 1 table, half bridge, 1 table, full bridge, another table. Right? So this is a way you got to do the experiments. Finally, you write the results. So today we are going to discuss about strain gauge experiment. The purpose of this aim of this experiment is to measure the Young's modulus of the beam. So here there are three important parts are there. See, this is cantilever beam. This is a cantilever beam which consists of strain cages. See, here you can see these are all strain cages. These are all the strain cages which is fixed. So what is strain gauge? Do you know what is strain gauge? The strain gauge is used to measure the strain. How it is measuring the strain? It measures the strain when it is subjected to loads. There will be a strain. So when it is subjected to strain or elongation, the resistance will change. The resistance is measured electrically. By measuring the resistance, you will be able to measure the strain. So in this experiment, you can get the strain. So here, the electrical circuit, as far as electrical circuit is concerned, it can be classified into three. That is, you know what is Wheatstone bridge. In the Wheatstone bridge, there are three type of circuits are there. One is quarter, another one is half bridge, another one is full bridge. So we are going to find the strain in this experiment using the all three type of bridges, quarter, half and full. So here we are finding the strain using the Wheatstone bridge, right? Here in the Wheatstone bridge, what it does, it calculates the strain. First it measure the change in resistance due to strain, that is converted into a strain. So after calculating the strain, you will be able to find the Young's modulus of this material. Young's modulus of the material. So here we are having a cantilever beam. In the cantilever beam, we are going to apply the load. We are going to apply the load. See, here we have to apply the load. When load is applied, the beam will be subjected to deformation. The beam will be subjected to deformation. When it is subjected to deformation, here strain will be developed. The strain will be calculated by the strain gauges. These strain gauges are connected with the circuit. Here, see, this is the indicator. Here it will it show the readings. So before that, here we have the connections. Here we have the connection. You can see here there are number of channels. Here there are number of channels. There are 10 channels are there. So for quarter bridge, we have connected with the channel 4. We can see channel is 4, and half bridge is connected with channel 8. Half bridge is connected with the channel 8. So this is a channel 8. This is channel 10. The channel 10 is for full bridge, right? So now, how to select the channel? To select the channel, we have a button here. So by rotating the knob, you can select any one of the channel. So if you want to use quarter bridge, then you have to select the channel 4. 1, 2, 3, 4. So this is the fourth channel. So here it is connected with the fourth channel. Then you have to select the 4. You have to select the 4. This is for, here you can see, here there is a quarter bridge, half bridge and full bridge. If you are going to use quarter bridge, then this indicator should coincide with the 1/4. So now if you want half, you rotate like this. If you want full, you rotate like this. This is for full. So similarly, if depending upon the type of bridge you require, you rotate this knob and select the quarter, half and full. So now we have selected the fourth channel, and here we have selected the quarter. If you want half, then you rotate this. Here you have to rotate to 8. You have to rotate to 8, right? This is a way you have to select the channel. After selecting the channel, you apply the load in the cantilever beam. In the cantilever beam, apply the load, and you take the reading. 100 grams, 200 grams, 300 grams, 400 grams and 500 grams. Then the reverse direction also we are going to find the strain. After finding the strain, we are going to calculate the Young's modulus. So this is a way the experiment is going to work. Now let us see how to do the experiment, right? So now we are applying the 100 grams. Now 100 grams. What's the corresponding reading? It is okay. You can see the reading. It is 55.5. Almost it is 55.5. So this is a strain.
So you have to multiply with 10 power minus 6. Now again he is applying the load. Now 200 grams. The corresponding reading is, you can take it. It is 113 into 10 power minus 6. Now he is applying the 300 grams. It is 163.5. 163.5. 400 grams. 216.5. 216.5. For 500 grams, 272 into 10 power minus 6. Now he is removing the load. For 400 grams, 222.5 into 10 power minus 6. For 300 grams, 172.5 into 10 power minus 6. So for 200 grams, it is 122 into 10 power minus 6. 122.5 into 10 power minus 6. Now 100 grams. For 100 grams, it is 71.5 into 10 power minus 6. 71.5 into 10 power minus 6. So this is the way you have to do the quarter bridge. Now we are going to discuss about half bridge, right? Half bridge.
6, 7,
8. Okay. Now we are going to do the half bridge. In the half bridge, now for applying the 100 grams. For 100 grams, it is 50.5 into 10 power minus 6. For 200 grams, it is 101.5 into 10 power minus 6. For 300 grams, it is 153.5 into 10 power minus 6. For 400 grams, two not 4.5 into 10 power minus 6. For 500 grams, 258.5. 258.5 into 10 power minus 6. For 400 grams, it is 203. 203 into 10 power minus 6. For 300 grams, it is 154 into 10 power minus 6. For 200 grams, it is 102. 102 into 10 power minus 6. For 100 grams, it is 51 into 10 power minus 6. Now we are changing the channel for quarter, for full bridge. So channel is 10. Yes. So this is full bridge. Now he is applying the 100 kg, 100 gram load. So for 100 gram, strain is equal to 51 into 10 power minus 6. For 200 grams, 100.5 into 10 power minus 6. For 300 grams, 151 into 10 power minus 6. For 400 grams, 200 into 10 power minus 6. And for 500 grams, it is 254 into 10 power minus 6. Now removing the load. For 400 grams, it is 201.5 into 10 power minus 6. For 300 grams, 150.5 into 10 power minus 6. For 200 grams, it is 100.5 into 10 power minus 6. And finally for 100 grams, it is 50.5 into 10 power minus 6. So now we have calculated strain using 3 Wheatstone bridges. What is quarter, another one is half, another one is full. So using this strain, by using the appropriate equations, you can calculate the Young's modulus.